In Lesson 4.8, you will be graphing dilations on a coordinate plane. You will also find the scale factor of a dilation. A dilation is the image produced by enlarging or reducing a figure. It's always going to be similar to the original figure. You can think of the word dilation as it refers to at the eye doctor where they dilate your pupil. They make it larger. It says draw the image of the figure after a dilation with center A and a scale factor of 2. A center of A, basically, it means that's the point at which it's going to enlarge or reduce from. Sort of like if I stuck a straw right here at point A and started blowing it up. If it's a scale factor of 2, that means it's going to make all the lengths of the sides twice as long. Since the center of dilation is A, A prime, or the new image point, is going to be in the same spot. But now D used to be 2 units away from A, so D prime, or the new D, is going to be 4 units away. Now C used to be 2 units above D. Now it's going to be twice that far away, so it's going to be 4 units from D. And then B, instead of being 1 unit above A, it's going to be 2 units above A, because it's going to be twice as long. So that's going to be B prime. Now I'm going to go ahead and connect those points. Your new image, A prime, B prime, C prime, D prime, is going to be similar to the original ABCD. The side lengths have gotten twice as long. Now what we're going to do is we're going to pretend that the point A is at the origin. So I'm going to go ahead and turn this into a coordinate plane. There's the x-axis. Right here is the y-axis. Now right there, the center of dilation is at the origin. We're going to write down what the original coordinates were and what the new coordinates were. A was at 0, 0. A prime is also at 0, 0. B was at 0, 1. B prime is at 0, 2. C is at 2, 2. C prime is at 1, 2, 3, 4, 4. And then D was at 2, 0. And D prime is at 4, 0. So if you take a second and look at the original coordinates and compare them to the new ones of the image after a dilation with a scale factor of 2, you'll notice that all of the original coordinates were just multiplied by 2. So both the x and y values were multiplied by 2. Once we multiplied those by 2, we got our new coordinates. right, so now that we figured that out, that you just take all of the coordinates and multiply them by the scale factor, we're going to go ahead and do this next example. It says to graph triangle JKL with vertices J, which is 3, 8. So I'm going to go to the right 3 and up 8. I'm going to label that J. And then K is at 10, 6. So I'm going to go to the right 10 and up 6. That's going to be K. And then L is going to be at 8, 2. So I'm going to go to the right 8 and up 2. And I'm going to label that one L. Now I'm going to go ahead and connect all of those points to make my triangle. All right, next it wants you to graph its image after a dilation with a scale factor of 1/2. A scale factor of 1/2 means we're going to take all of these coordinates and multiply both the x and y value by 1/2. So J prime, use a different color here, J prime is going to be to take these coordinates and multiply them by 1/2. So 3 times 1/2 is 1.5. And 8 times 1/2, or half of 8, is 4. So I'm going to go to the right 1.5, so that's between 1 and 2, and then up 4, and put a point. I'm going to label that J prime. All the new image points have that little prime symbol. Next we have K, which is, K prime is going to be 10 times 1/2, or half of 10, which is 5, and then half of 6, which is 3. So I'm going to plot 5, 3. I'm going to go to the right 5 and up 3. And I'm going to label that one K prime. And then the last point, L prime, we're going to take 8, 2 and multiply both of those by 1/2. 8 times 1/2 is 4, or half of 8 is 4, and half of 2 is 1. So I'm going to go to the right 4 and up 1, and I'm going to label that L prime. Now I'm going to go ahead and connect these points. You should have a triangle similar to the triangle you started with, but the side lengths are half the length of the original. One other thing that's kind of neat is if you wanted, you could take a line from the origin and it should go through the corresponding vertices in a straight line. So that kind of helps you to see if it looks right or not. You should be able to draw some lines from the origin through the corresponding vertices. All right, if we look back at those two dilations we did, a dilation with a scale factor of 2 made the new image twice the size, the lengths of the sides twice as long. And when we had a scale factor of 1/2, our new image was smaller than what we started with. So if you have a scale factor larger than 1, it's going to be an enlargement. And if you have a scale factor that's between 0 and 1, it's going to be a reduction. All right, now the last thing we're going to do is find the scale factor. To find the scale factor, you want to write a ratio of the x or y coordinate of one vertex of the dilation to the x or y value of the corresponding vertex of the original. So we're going to compare the new one to the old one. and you're going to pick either the x or y of a corresponding point. So if we look at this one right here, I'm going to try to choose a point that is easy. I'm going to go ahead and choose this, E prime and E, these 2 points right here. And I have to choose either the x or y coordinates. I don't want to choose the x coordinate for these 2 points because the x coordinate is the same thing. I'm going to go ahead and use the y coordinate. The y coordinate of this point, remember we're doing the new one compared to the old one, that y coordinate is 2. And the y coordinate of the old one is 1, 2, 3, 4, 5, which means that the scale factor is 2/5. Since it's a number between 0 and 1, it's going to be a reduction, which makes sense because when you look at the picture, the new one is smaller than the original. Try one more here. I'm going to look at A and A prime. Remember, you compare the new one to the old one. I don't want to use the x value since it's the same, so I'm going to compare the y values of the new one. 1, 2, 3 is the y value of the new A or A prime, and then the y value of A is 1. 3 over 1 is 3. Since that's a number larger than 1, it's going to be an enlargement. The key here is to remember is you're going to compare the new image to the old or the original.